so I will start recording as well. Good morning, everyone. Let's get started. So we're going to talk partial order planning today. Um, Before we start, just a quick recap. Uh, just, so in last lecture, we have specifically looked into state space planning, right? So, so we have seen state space planning, and in this planning there is there are states, and in between states there is actually search, right? So there are two type of things we have seen. One is progression and one is relation. Progression is also called forward search, and regression is also known as backward search. And we have seen some example of each of these state space planning, right? Before that, we also talked about like how actions and actions are represented using precondition and effect. So let's start from there. Today's lecture is we are going to talk about partial order planning. So before we know what partial order planning is, let's try to formally write some of these things like Excels in a formal way. So today's agenda. So we are talking about like what is plan, what is partial order plan, or known as POP. We'll discuss a couple of examples of partial order plans, various concepts related to partial order plan, and we'll also have a small quiz towards the end of the class. All right, so let's talk about partial order plan. But before that, let's understand back the representation of action itself. So representation of actions. I've seen it, but let's try to formally write. So let's say we have an action called go y. Right? So this is an action. Go y. Go y. So if you are asking a agent to conduct this expression or execute this action, then how do you write? So you are formal way. So two ways we will learn. One is like functional way. So we have seen like this. So we write OP for this is for operation, right? And then we have a action. So what is the action? We write like action is go y, and then there are precondition and effect, right? So we write precondition and effect, and close it. So what is the precondition of go by? Yeah, reference links I will share today. Yeah, it's mostly from the yeah. So most of the things what I'm covering is from chapter 11 of the textbook, which is uh, uh, which version I have to see, but I'll give you the PDF and also the link you can look into. Okay, so what is the precondition? And precondition will not be like precondition should be like you should be like at X maybe. X is something. It should be at X, and there must be some path between X and Y, right? There must be path between X and Y. Then only it's possible to have. Uh, so what will be that? There exists a path between X to Y. Then only you may able to go to y, otherwise you may not able to go to y. So this is the precondition. You are at some position x, and there is a path between them. What is the effect? If is you are no more at x, right? But you are at y, right? So this is one way of representing actions, which is like a very formal language. You have action, preconditions, and effects, right? So the other way of representing action is a graphical way, right? So graphically is very similar to this, but you can have a look into that. So graphically, when you represent, what you do is you have a action. Action is usually represented inside a rectangle. So go Y, and uh, you draw a line out of it, right? So if this is executed, then the precondition is written here. So precondition is here and is here. So, so this is useful when you draw the plan diagram. So this is when you have this, this is at x, and there is a path between x, y, and the effect is you are at y and not at x. So when we write effect, that doesn't mean that some of the things which we don't write are not true, right? For example, path xy is still true, right? So at this position, path xy is still true, but we are not writing it, right? So we don't have to write everything as effect. So effect, usually when you write effect, you mostly talk about what is added and what is deleted, right? So what remains is same. So what is added here is at y is added and at x is deleted, right? So you have add and delete, but path xy is still true. Like after executing this operation, still there is a path between x and y. Right? So that's anyway true. All right, so this is a representation of like action. But now let's look into, because what is a plan, right? So plan, because our lecture is like about partial order plan. So what is a plan? Right. So plan, like in a principled way, has four components. So it has four components. What are these four components? The number one component is states, right? So any plan will also always have steps. A set of plan steps. Each step is one of the operation for the problem. Right? So it is, you can write it like each step is one of the operators, and these things like operators, actions, they are interchangeably used. Operators for the problem. All right. So each step is one of the operators in the problem. For example, go to Delhi. Go to Delhi is a step. That's a step we are talking, and like a plan always contain a set of plan steps. Right? So plan always contain a set of steps. The second is ordering. In a plan, it is always very important to have order between these steps. So you cannot execute anything like things at random, right? So there is this concept of ordering. So there is a set of state ordering constraints. Right? So we can write it like a set of states ordering constraints. Each ordering constraint is a form. So each ordering constraint is of form Si Sj. So the notation Si is kind of less than Sj. Right? Si is before Sj. So it means that it means that the step Si has to be executed before Sj. Right? It doesn't mean that SI has to be executed just before SJ, immediately before SJ. Does not say that yes, that SI must be immediately before SJ, but it just says that SI must occur before SJ. For example, if you are talking about planning to bake a cake, then there is there is a steps ordering, right? So there's steps like having having milk and flour and other things or egg. That these are the previous steps. They has to be occurred first. You need to act upon that first before baking the cake. So, or if you are planning for travel, there are set of steps like buying ticket. So buying ticket has to occur before like traveling or flying. Let's say. So this is a set of steps ordering. So we have seen steps. Steps is nothing but operators ordering the set of steps ordering constraint. Third third thing. What is the third thing? A set of variable binding. So this is something. So this is called binding. What is binding? A set of variable binding. A set of variable binding. So this is a form p equal to x, right? So the b is a variable. What is it? We will see. B is a variable and x is either a variable or a constant. It can be a variable, it can be a constant. For example, when you say by x, right? So a set of these operations or steps will not be like exhaustive. Like you will not have all the list you are buying. It will just have a variable or it will have a schema like by x. So whenever you say by x, at certain step, you need to bind that x with something, right? So maybe buy a banana or buy apple. So that binding, that's all. That is what is called binding. So okay. And the fourth and important step is called causal links, right? So fourth is a set of causal links, right? So what is causal link? A causal link is nothing but so let's say you have a step Si, you have a step Sj, and so Si achieves C for Sj. So this is read, and this you can read as SI achieves C4SJ. What does it mean? So it means that there are two steps, right? We'll see examples anyway, but let's say you have two steps. And the step, let's say you have a step like maybe, let's take an example. Say you have like something like Go Store, right? And let's say buy buy Apple. Right? So this is S1, this is S2. What is the precondition of buy Apple? You need to be at store, right? So it should be like the preconditions should be at store. Precondition of buy Apple is at store. So S1 and S2, there can be a causal link, right? So this is called causal link. Causal link is, so S1 is this is your C, and this is your S2, right? So C is the precondition of S2, and C is the post condition of S1, right? So C is a post condition of S1, and C is a precondition of S2, and then you can link S1 and S2 using causal link. So you need to have such causal links like in to define a plan. All right. So we have seen now that the plan consists of four things. One is a set of steps. Second, steps is nothing but you can think that as operations. Second is ordering constraints, a set of ordering constraints, like which step has to be executed before which step. Third is binding, like a set of variable binding, because originally your operators are not like binded to something, so they are just in a raw form, like schema form. But while defining a plan or defining a plan, you need to bind these variables. And the third is causal links. Right. So, any questions on this before we move to one example? So just give me a minute. So let's say there is a like let's take this example, how you define a plan, and or how do you define the initial plan, and then how to define those things. So let's take an example. So we're taking a very simple example of putting on shoes, right? So putting on shoes, uh, like you have two shoes and two socks. So there is some order there, right? So like what is the order? So let's first of all write it down. So the order is, you can either put left sock, or you can put right sock. Right? After left sock, you can put left shoes, and after right sock, or you can put right sock, right shoes. Right. And if you say this is your start and this is your finish, this is start, this is finish, Then this is the order, right? So this is I'm just trying to give the example here where you now here what is happening is either you can put left sock or right sock, right? So you have the flexibility there. But once you put left sock, then only you can put left shoes. Once you put right sock, then only you can put right sock, right shoes, and so on. Once you have done both, then you are finished, right? So we'll see the example in slightly more detail. But this is the example. Let's say you're trying to do, and for this, uh, so. We for any of this planning problem, what we do is we add two dummy operations. Okay, one is called the start operation, and one is called the finish operation. So maybe we can draw like this. One is called start, and one is called finish. So these are dummy operations which you add. And now you can think like there is some precondition to this any of the action, right? So any of if you have any action, always there is a precondition and a post condition. Go to next slide. So we said first thing is we add two dummy steps or dummy operations or dummy steps. So this is start, and this is finish. Now, can anyone tell me what is the precondition of start? What is the precondition of start? Start is an state. It's an operation, right? So, or a operation or a state, you can say. Yeah, so no, so start, there is no precondition, okay? So the precondition is empty, nothing is there for a start. For finish, there is some precondition. Finish precondition for this example is the shoes example is right shoe on, left shoe on. And the finish does not have any post condition, or it does not have any effect, because finish is the end goal, right? Start has no precondition. Start has precondition is empty, I said. So precondition is nothing, empty here. Here its effect is empty. Precondition is empty for start, but and here we have a precondition here. But the effect of a start is the initial condition, right? So initial condition means like, yeah, so if initial condition is there, that will be the effect of a start. Like you are when you say start, you can always start without any precondition, but once you start, you reach to the initial condition, or initial state. So in initial state, but there is no initial state in this particular example where you have left shoe on and right shoe on. So because there is nothing there, so you don't have nothing to write there for the start as well. So there is no effect of a start. You just start from there. Okay. So now what you do is now you can have some ordering constraint here. Yeah, that's true. If you think like that, means if you do not assume that shoes and socks cannot be there, also if you assume like that, then that's the condition. But so initial state is the effect of a start, right? So we are here, we are assuming that those things are anyway there, shoes and socks. So we are not really worried about whether that is there or not, right? So the precondition effect of a start is nothing there. Precondition is anyway nothing. So now, can you think something about these two operations, S1 and S2? Can you say anything about the ordering of S1 and S2? Anyone? Is there any between? So this is S1, right? So this is, let's call it S1. Let's call it S2. Is there any ordering between these S1 and S2? S1 has to occur between before S2, right? So S1 has to, this is the ordering. S1 must occur before S2. Must start before it. So it's very, very trivial ordering thing. But there is no causal link. You cannot really connect S1 and S2. Why? This is wrong, right? So maybe you can draw that using red thing. This link, right? So this link is not correct. Why that is not correct? Because for causal link, if you remember, let's go back to the causal link definition. So Si achieves C of Sj, right? So the precondition should be achieved. Precondition of S2 is left so on, right so on. That is not achieved by start, right? By start, that is not achieved. So there is no link, or there is no causal link between start and finish. The thing we are saying that ordering link is there, of course, that S1 must occur between S2. So there is an ordering link, but there is no causal link. Okay, is that clear? Yes. Okay, now this link is not allowed. Now, what we do is we look into each of these preconditions of the finish state or finish step and try to satisfy that, right? So let's look into the precondition like left shoe on. This is a precondition. This is satisfied. This is not satisfied. What will satisfy this precondition? What will satisfy this precondition? This precondition will be satisfied by action, right? So some action. So put left shoe, right? So left shoe. Sorry. Put left shoe will satisfy this particular left. Sorry, this will satisfy the. Oh, okay, just a minute. It should be right shoe, right? So it should be put right shoe. Put right shoe will satisfy put right shoe on. Right? So then we can have a causal link, right? So we can have a causal link between this S3 and finish S2. Why there can be causal link? Because one of the condition is satisfied. This is your C. This is the causal link there. So one of the condition of S2, precondition of S2 is satisfied by having S3. What is the precondition of S3? What is the precondition of S3? Put right shoe. What is the precondition of S3? Anyone? Put right socks. Yeah. So the put right socks, put, or maybe not put right socks. So the precondition is that should be on, right? So you put precondition should be right shoe, right socks on. Okay. So right socks on is the precondition of this particular thing. Is that satisfied? Can we have a direct link, causal link from S to S3? Can we have a causal link from S1 to S3? No, because that is not getting satisfied. We need to have some operation to satisfy that, and that operation is put. That operation is put right sock on put right sock, right? So that's the operation put right sock, and that is being satisfied, and then there will be a causal link between these two. Now put right sock, there is no precondition, right? So means we are assuming that this is initial thing. So then we can have this link there. Anyway, that's fine. And similar way, you can have a link in this side with the left. Okay, and left source. You can have similar. So you're like we have put right so this side and left in the this side, and you can have this plan now. So this plan is now there are some certain ordering constraints you are adding with each time, right? So there is some kind of ordering constraint you are adding, and there is some causal links also you are adding. So you have how many steps? S4, S5, and S6, right? Now S4 and S6 there is no causal, there is no ordering, right? So S4 and S6 there is no ordering. Either you can put right sock on or left sock. It doesn't really matter. So S4 and S6 there is no ordering, but there is an ordering between S4 and S, right? And S4 and S5 are not connected, so that you cannot do, like you cannot just jump into things and do things. So there is none of order and causal link. Is that clear? So how do we write this plan, initial plan, in the formal way? So initial plan will be written as this. So you have plan, right? I said plan always have four things. One is steps, one is ordering, one is binding. So here there is no binding happening, but we'll see some more bindings, good examples of that. Orderings, bindings, and fourth one is links. Or causal links, right? So this is the plan. Plan is always written in four things. What are the steps we have? I'm talking about just the initial thing, right? So of course you can for all the things. Maybe your exam question will be like that to write all the steps, right? But here I'm just trying to write the initial step where we have a start and finish. The initial step, one of the thing operation S1. S1 is nothing but an operation action, right? Operation as a action is start, and there is no precondition or post condition of that action, right? So start is there is no precondition, no post condition. S2 is another operation, action is finish, and it has some precondition, right? So the precondition of this, in order to finish the thing you need to satisfy this. The thing is right so must be on, and left so must be on. So it is and, right? So and left so on. Right so on, left so on, that's the operation S2. Of course I'm not writing all the things, right? As ideally you should, when you write for everything, you need to write for S3, S4, S5, and S6 as well in this particular example, and you will have more ordering, but I'm just writing for the beginning case. What is the ordering? S1 has to be before S2, right? And there is no binding here, there is no link here, they are empty in the initial thing. But yeah, so effect of S1. No, there is no effect of S1, right? So if you look into this example, S1 is just, there is no precondition, there is no effect. So S1 means just you're like starting from zero. There is nothing. There is no effect, no. But some cases there will be. We will see examples. One more example where there will be effect of S1 as well. But here you are assuming that S1 is like a start from zero. There is nothing. Effect will not be put socks on. No, put socks on is not the effect, right? So what is there is no precondition effect of a start. So a start pre put stock on is a step. So this is an step, and this step does not have any precondition. Put right sock, that does not have any precondition. You can put it, right? So you can just put it. So there is no precondition. So you can directly link it. There is no precondition here as well. We can directly link it from the start. Okay. Okay, so let's take one more example to understand it more clearly. Yes, so when ordering combinations need to be written related to all steps, all ordering combinations. So yeah, means so you do not really write all the things because all sometimes when you don't write, that is let's say S3 and S5, right? So you don't write that S5 should be before S3. You don't like that, so you only write the like things which are important to write, right? So you also give some amount of freedom, right? So for example, S4 and S6, you don't write that S4 should happen before S6, or S6 should be born before happen before S4. So you leave it to agent to have some free will in a way. So so that he can do either, the agent can choose to do either S4 or S6. It doesn't really matter. But the things which matter, that you should definitely write. For example, S4 should happen before S3. That you should write. Okay. Let's take another example, which is also in the book. Uh, this is an example of some initial state is given, and you want to purchase, you want to have a book, you want to have biscuit, you want to have tea, and you want to be at home, right? So let's look into the initial and condition and in condition. So our S1, as I said, states S1 is to us, given to us, or S1 is this. So S1 is nothing but an operation. The action is start. Start. Okay. So action is start. So what is the a start action precondition? There is no precondition of start, because start is like you can start from beginning. So precond is nothing but your effect is there. What is the effect of this start operation is as follows. You are at home. Okay, you are at home, and then there are some universal truths like cells. BS stands for bookstore. bookstore sells book. Okay, bookstore sells book and sells tea store sells tea, right? And sells tea store also sells biscuits. So this is your start state, which has no precondition, but at ground zero or at the beginning, you are in this stage where you are at home. There is a bookstore which sells book. There is a tea store which sells tea and biscuits. Now, from here, you have to reach to the S2, the final state or the finished state. The finished state, how do you write? So here we are writing it like this. Action is finish. What is the precondition of finish? Precondition of finish and effect of finish. So precondition of finish is you need to be at home. Okay, so you want to come back to home after having all this, right? And you need to have book like this and have tea and have kids, right? And the effect is nothing. All right. So S2 is the another action, which is the final goal of this thing. You need to be at home. You need to have a book. You need to have tea, and you need to have biscuits. Okay. So this is S1, S2. Another thing is set of operations is also given. What are the set of operations? Two operations. So operations, because in order to plan, you need to have some set of operations, right? So the one of the operation is Y, right? Another is by X. Okay. Go Y and by X. What is the go by thing? We have already seen. You already know what is the go by effect and what is the precondition. Maybe quickly I can write it here. Precondition this side, effect this side. Precondition is you need to be at X, and of course you should have path between X and Y. That's, let's say, assumed, and you will not be at Y. Sorry, you will not be at X, but you will be at Y. By X is you need to have at a store, right? And the store, you need to be at a store, and that store should sell that X, right? And here we are not assuming that you should have money at all. Of course, as I said, like so many times we assume a few of the things. Yeah, path of X, Y is also precondition to go Y, but for simplicity, we are not. We are assuming that something are like okay, that are trivially true. Path between X, Y is there because of all the conditions you cannot really model, right? So that's why we are uh, working with some of the assumptions. For example, for buying something, you need to have money. So but we are not writing that. Or when you buy something, the effect is also that your money will be like less after that. We'll spend some money, but all the things we are not really writing, simplifying the things. So buy X is at a store, sells X, store XY, and what is the effect of this? Is have X, right? So you are having X, because for example, so this is X is a variable here. So by banana means you need to be, store is also a variable, right? So store is some variable, and that particular store, let's say the fruit store or something, or fruit corner, sells banana, and have banana is your effect. So these are the two operations. These are the two S1 and S2. Now we're good to go. We will draw the partial order plan, right? So partial order plan is, why this is called partial order plan? Because we are not giving the total ordering there, right? So we are only talking about partial things. We are not giving everything possible, right? So if you give everything possible, that's called total order. Book has an example on that, so you can have a look into that as well. But here we are talking about partial order. So let's start. We have a start, we have a finish. Finish has a few things, right? So one of the thing is app, book, and and e, and have biscuits, and at home. Okay. What is the start state here? You are at home. You are at home, and then there are these things like sales, BS, book, and sales, TS, T store, sales T, and sales T store, also biscuit. Now here start and finish, right? Finish has some of the preconditions. One of the precondition is already satisfied. That is at home. Like so even in the start, there is a at home. Without doing anything, you are at home. So that is being satisfied. So you can, that way you can think like there is a causal link as well from the start of this. This is your S1. This is your S2. Now, but the other things are not satisfied. So what is not satisfied? We need to try to satisfy that. So for example, have book is not satisfied. What will satisfy have book? What will satisfy this have book? So that we can have a causal link between that state. What will satisfy that have book? Buy book, right? So buy book will satisfy. In fact, buy X will satisfy you, let's say, because we have only buy X, right? We don't have anything like buy book. So buy X, but X will be banded to a book. That's called banding. So X is by X. By X will lead to have X. But what is the precondition of by X? You need to be at something that's called G, and and sells G book. Right? You need to be at G, and G sells book. That's a precondition of buy X or buy book. So is that satisfied? At G, right? So at G is, in this case, G will be binded again. G will be binded to bookstore. You are not at bookstore. Bookstore sells book. that is fine, right? That part we are taking care from here. This part, there is a link file from here. But at G is not satisfied. At G will be satisfied by which action? So this is your S3. At G will be satisfied by what? Go, right? So that will be satisfied by, right? To buy the book, you need to be at bookstore. You are at home, so you need to go, right? So you have to go X, and here again binding is happening here. X is binded to bookstore. Go to X. X is binded to bookstore. And what is the precondition of go X? With the precondition of go X, you need to be at some place. They go to, at Y, right? So you need to be at Y. At Y, here Y is binded to home. It's there. So there is a precondition satisfied there at home. Right. So without doing anything at home to go, you can go to book, right? Y is equal to home. Yeah, you can go to X, go to bookstore, and after going to bookstore, you can buy X, that is buy book, and have book is satisfied. This part is we have done. Similarly, we need to see other parts, but here there is a problem. So what is the problem? Go to bookstore has also has one more effect. What is the effect? If you remember, go to bookstore is also creating a side effect. Let me draw it in a red color. I don't know whether that's visible to you guys. So when you say uh, you go to X, right? So when you say go to X or go to bookstore, you are no more at home, right? You are no more at home, but you are at bookstore. So from there, you cannot really go to tea store, right? If you directly jump from there to tea store, that will not work. So we can draw this other parts. So other part will be like you will have buy tea, buy biscuit, and for this will be satisfying this will be also satisfying this, and for buying big this you need to go to tea store, need to go to tea store. Maybe you can write it two times, but that's essentially the same, so we can omit that writing two times. uh, Here, right, go to tea store, and that's there. But now here you can now see that to go to tea store cannot be really connected to like start here, right? Because that can that so there is this ordering constraints is playing a role here. One of them is called promotion and one is called demotion. I recommend you to look into more into the book. But here, what is promotion demotion is you can actually finish this ordering has to be specified like these dotted lines, right? We first finish this and then go to tea store, or uh, you first buy these things, right? So you can buy yeah, so here also like before finishing, right, you are not finishing things. So after buying this, so you need to have something like this also uh, you can do. So there is two things, you do two orderings we need to add. Either you buy both these keys and biscuit and then go to bookstore, or you first buy we complete this buying book and then go to tea store. Okay, so this is there is some kind of serialization you need to do. You cannot it's like you cannot really jump from go X to go bookstore to go tea store and do things, because if from go bookstore, if you go to go tea store, right? So go tea store, the precondition for that is like you need to be at home, and that's not satisfied. So that needs to be taken care, and this is called threat. So this is what is the threat here? So formally, uh, let me write it formally more. So talking about threat. Sure. So conflicting actions, right? So conflicting actions cannot be done in between, right? So you have, let's say, S1 and S2. Okay, there is a precondition C, which is for S2 to be happening, but there is another step which is S3. The effect of that is, let's say, negation of C, right? So then you need to first either finish this S1, S2, and then do this S3. So in maybe using, right? That's one way. Or you can first do S3 and then you do S1, right? So that's two way of doing things. Dotted line does not satisfy the precondition, that is after by biscuit. Hmm. No, so you don't have to be at home for to go to big store, right? So you can go. The only thing, if you look into like go, is you are at some position and you are at some position, right? So it can be X and Y can be binded using either bookstore or tea store or what do you say, bookstore, tea store or home. So here that is fine. So you can actually go from tea store to book is right. So your precondition is just at Y, right? So your binding will be different. But the problem here is like it is creating you are not at home. Uh, just a minute. So that if you just connect that, then what will happen is you will not buy X and you will go to two store. That's the problem, no? Yeah. Just give me a minute here. Hmm. Okay. This is like thread, and this thread we need to what we need to resolve. Right? So resolution is done using. So maybe this dotted lines. Let's not be confused. Maybe the only thing is you need to know is there is some amount of serialization you need to do. You cannot do an conflicting actions in between. That's the major thing to be you should know. So one more thing I would like to discuss is what is a complete plan? Okay, what is a complete plan? A complete plan is one in which every precondition of every state is achieved by some other state, right? So is a plan, right? It is a plan in which every precondition of every step is achieved achieved by some other step. So this is called complete plan, and there is no contradiction in ordering or binding. There is no contradiction in ordering and binding constraint. For example, if I have a ordering like let's say S1 should happen before S2 and S2 should happen before S3, and then I say S3 should happen before S1. This is not allowed. Why this is not allowed? Because you are contradicting things, right? So you are saying that S1 should happen before S2, S2 should happen before S3. That also means that S1 should happen before S3. No, that's a transitive property. It should follow that. But you are saying no, no, S3 should happen before S1. So this is a contradiction. So such contradictions are not allowed. And all the preconditions should be satisfied. Then you say that this plan is complete. And what is the solution? So let me define it from the book itself. A solution is a plan that an agent can execute. Solution is always complete and consistent, right? So it has to be complete. So complete and the consistent is complete is one. Maybe I'll also talk what is consistent. So a consistent plan is a plan in which there is no contradictions in the ordering or binding. Right? So this is consistent. Consistent is no contradiction. So if a and what is a solution? A solution in context of POP or partial order planning is nothing but a complete and consistent plan. Complete and consistent plan. Right. So now I will take one example to maybe you can ask a question now so that you can understand this part. Just give me a minute. Okay, we have image. Okay, the example is ready. So now you can see it. Okay, so in this example, can you tell me why this is not complete or consistent plan? Like what is wrong with this? What are the wrong things? There are few wrong things in this, a few incomplete things in this. What are those? Multiple options to finish. Yeah, multiple options to finish is fine. That's not that is so yeah. So there can be more solution. Solution means there is one plan, right? So as a solution, but you always have options. There are loops. Where is the loop? So what is not getting satisfied? You need to see now. PA is satisfied. OAB is satisfied. Pre-A, pre-B satisfied. Smooth P. You can see some of the conditions are not getting satisfied. So maybe I can draw like smooth B is not satisfied, correct? Right? This is not satisfied. Uh, Assemble AB threatens pent A by its effects pre-A. Is there any threatening happening here? There is a threatening happening here. Is this is the threatening, right? So if you look into this pre-A, this that also means that you cannot really first assemble and then paint, right? So there is some ordering constraints created, right? So you cannot really assemble. The effect of assemble is not free, and the precondition of paint is free. So you need to have some ordering constraint between assemble and paint. It's not like you first choose assemble and then do paint. That's not possible. So you need to have that ordering constraint here. Assemble AB also threatens paint B, right? So because this B, 3B, the last and not the list is assemble AB threatens and A, right? Because the precondition of assemble is not pre-A, but here this is pre-A. Yeah. So there is a lot of threatening happening. So now I think you have an idea of what I mean by the threatening of threats, right? So threats is something where the effect of some state negates the precondition of the condition of another state. And in that those cases, you need to have some kind of a realization needs to be done. It's not that you do this and do that, right? So that's not always possible. You need to have some kind of a realization which needs to be done. Okay, so now we have less time. Thought I would have discussed the algorithm, but maybe that we can do tomorrow. And tomorrow we're also going to discuss graph plans. We can have plan to have one more lecture, extra lecture in the next week because we are flying slightly short. Or I can give some material to read, but the assignment is already up. Okay, so the assignment is. having six questions or six problems. But what is allowed is you can actually work in, okay, like you can maybe form your group yourself, three people, and we this will not be too loaded, but you should practice it well. Whatever questions are given, similar flavor questions can be expected in same as well. So uh, that you do and submit on time, because there is enough, because there is not much of questions, two questions kind of. If you form a group of three, it is just a two question, but you should understand all the questions. It's not like someone is doing. So now I'm posting quiz, but before that, let me see if I can do that now. General setting, unlimited question, timer, no leaderboard, shuffle. Okay. Yes. So the quiz will be again on the quiz.com. Just let me share my screen. Quizzy.com. So you don't have to go and do anything. You just have to so wait for a minute. Join this using this particular code and write your full name, right? So when it asks to write your name, you need to write name. Okay. So can you guys start? Join myquiz.com. Just five questions are there. 39019252, and write your full name. I hope everyone started this. Join myquiz.com. If you want, I can copy it. Everyone. Okay. So Okay, so do not attempt two times. Time is over, right? So whatever is it's 9:25. Uh, Whatever is your first attempt, that will be counted, not the second one. Which among following is not fluent is the adjectives XY, because fluent always have situation like at that particular situation. So S variable is always there. Um, and if there is no S, these are like called atemporal predicates, not fluents. Right? For instance, XY, this is like atemporal predicate, not a fluent. Consider following steps S1 and S2. Right, so in S1 and S2, right? So S2 has to be, there is a constraint, right? So S2, this is wrong, this answer is wrong, but what is the right answer is S2 has to happen before S1 because the precondition of this is B, right? So that precondition has to be satisfied to happen this S1. So this is important. Like you need to have precondition because if there are two steps given here, precondition need to be satisfied to happen. A solution in the planning is obviously I discussed complete and consistent plan. This is a block world problem. I hope the answer is 1, 2, and 4, right? Because on xz will not be true. It will be after doing all this operation, x will not be on z, right? So this will be false because we are doing something differently. What are we doing? Uh, is the initial state. Now if you apply put x on y, right? So if you are doing x on y, then this will not be true. X is not on z now, x is on y. So this is there. Last, there are two conditions which were true. Some of you have marked one, but ordering in partial order plan should follow transitive property that we have seen, and have money and at store is precondition to buy pizza. Right? So that's very natural precondition. There was a question like still pizza. For a still pizza, you don't need to have money. So if you are just at a store, you can still pizza, but to buy, you need to have one. Okay, so that's all. Let's meet tomorrow. I recommend everyone to post the book portion which I am referring to in the classroom. I encourage everyone to look into that part, and so that we can discuss that tomorrow. Okay, bye. Have a good day. See you tomorrow.